Now, transport layer, what it does is it is exactly responsible for the end-to-end delivery of files or messages or whatever transmission you have to do. Now, session layer, it creates the logical channel, it maintains it, and it closes it. But this transport layer is responsible for the transmission of each and every packet, each and every like bit of data that has to be transported. The next would be my network layer. Till here, we talked about the till here we talked about the logical connections. Now this network layer is responsible for the physical communication, physical channels, the physical path that has to be taken. It would be followed by my data link layer. Data link layer. Now this data link layer is responsible for the format of the data that is being transferred or that is being shared. Now let us talk about what are the things that would be used. We discussed how they would behave. Now the first layer that we are talking about is the web application. Suppose I am using a mail. So the application that I am communicating with is my mail, and that is the web application I am using. Now the presentation layer would be responsible for the encryption, decryption, and all those things. So the protocol normally that would be used, that might be HTTP or HTTPS, depending upon the kind of uh, application that I am interacting with. Now, in case we talk about the session, so port 80, port 81, or whatever port might be used, that would be uh, decided here. Now, in case we talk about the transport layer, so it will decide which protocol to use. So an example can be my TCP protocol is being used for my transmission. In case I talk about the network, so it can use might be the internet protocol, any of the internet protocols. Now, in case we talk about the data link layer, it is doing the physical thing. So it will take care of my Ethernet channel that I am using. So the last and the physical layer that I am interacting with, that will be involved in the transmission of bits. So that might use Cat5 cable. So this is how my OSI model works. Now, I hope that was clear to most of you, but in case anyone has any question, just let me know. No, I hope many of us were. Someone is trying to say something. Fine. So many of us in the previous days were like, uh, mm, fine, nothing. Fine. So let us talk a little about the TCP IP model layers. So that is again needs to be. So let me this sorry. The highest layer would be the application layer. That would be followed by my transport layer. That would be followed by my internet layer. And that would be followed by my network interface layer. Now, in case we talk about what are the different things that are being done by my application layer. So everything that I was doing with the application presentation and session layer is being taken care of by my application layer here in the TCP model. In case I talk about the transport layer, that works exactly as what we are having in our OSI model. In case we talk about my network layer, that is what is my internet layer. And the physical and the DLL layer, they might be taken to be my network interface layer. So the things work like this. I hope that was clear for most of you. Now, we were talking about the different protocols. The first protocol that we were discussing was my TCP protocol. So let us not run into the theoretical part. Let us talk about the packets. Now, this is what we have been discussing, that a large chunk of data or a block of data is broken down into packets for transmission. Now, every packet is broken down based upon certain logic or certain concepts. So the protocols define how I am going to create my packets, and we have discussed a normal data packet, how it looks like, and what would be the various fields. And mostly we would be working on 32-bit addressing of my protocols. So in case I get back again, let me take this 32-bit packet. The lowest one, let me take as my payload or data. The exact data bits that I am going to send is there in the data or in the payload column. You might call it either. You call it payload, that would be good. You call it data, that would also be fine. Right. So that is to make sure that you guys do not get confused. So let me take the data. So a total of 32-bit packet is this. This is my 32-bit. Now you guys do not need to get confused, or you guys need not worry like how do I do. You are not going to do anything on this. You just need to understand. Even if you do not understand, this will not make any difference, since all this packet making, reception of packet, and everything would be done on its own. You are not going to create data packets. That is not your job. That is the job of my layers. So they would be creating the packets, they would be sending over the packets, and they will do everything. You just need to understand how to create a communication channel. Bas. So 32 bits, 0 to 15, many of the people, they find it really confusing. Like, yaar, ye itna, how do I remember all this and everything? So don't worry about anything like that. So 0 to 15, this is the number of bits. So this is 0th bit, first bit, second bit. Now we don't be having anything in between normally, except in the flags column. So I am taking 0 to 15 and to 31. Now the first would be my source port and the destination port. I hope previously also we have discussed that this would be one of the most important thing about a data packet, so that I find the source port and the destination port, or the address. We can call it source address or destination address field, or source port or destination port. Now this is what we discussed in communications, where it is a kind of uh, suppose we are using some kind of in case we are not creating a logical channel between two data, between two devices. So what happens is most of the devices, they would be getting these packets. Now the problem arises ki this packet was not meant for, suppose, Mukesh. This was supposed to be meant for Ganga. Now what happens is Ganga also gets this packet, Mukesh also gets this packet, but this was not meant for Mukesh. So what happens is it is having a address ki this has come from Nashit and this is meant for Ganga. So Mukesh does not open this packet. Mukesh understands that this was not meant for me, so I am not going to use it. So similarly, this destination port and the source port will do this कि no one of the non-intended user uses this packet or processes this packet. So I hope this is clear for most of you. Now, the next is my sequence. Now, this sequence is something like my index number or my page number. Like most of the books, you have seen the page number. Now, what happens is when you are printing a book, it doesn't come like that. You have the page numbers everywhere and it is not binded. Now, somehow by mistake, in case you are not printing in the uh, page number and you are getting a stockpile, and what happens is somehow you turn on the fan and all the papers get hayward. Now you cannot match up which paper to put in where. So to overcome that problem, we came up with this page numbering. So you have page numbers. Now even if they go hayward, it might be a little tough, but you can arrange all the pages in the correct manner. Similarly, we have the sequence number. Now, suppose I have a channel and one of the packets, it meets delay and it gets uh, transmitted or received by you at a later time. So you still have the sequence number. Once you process the sequence number, you can put each and every packet at its correct order, so that the complete uh, message or the complete like all the packets are arranged in such a manner that they make the correct meaning of the data that was sent to me. It would be followed by something called my acknowledgement number. Now, what these acknowledgement signals do, uh, similar to my sequence number in a particular communication, these acknowledgement numbers will signify which communication, for which logical communication this data was sent. Suppose in a matter of 30 minutes, I have a sender, I have another sender, and I have a receiver. I request these senders to send me a particular file. Again, I ask them to send a particular file. And I again ask this to send a particular file. And then again to this. So we talked about the synchronization, the sync bits, and everything. So each time a communication is a channel is created, the receiver will get a packet that would be having an acknowledgement number which will signify for which communication channel was this packet created. This would be followed by another layer. The first would be my header length. That would be 4 bits of header length, H length. So that would be 4 bits. That would be followed by another 8 bits of 6 bits. Yep. Let me get back to that. So that would be another 6 bits. That would be so instead of this 4, this would be 3. There would be reserve bits. Now we have since long been talking about we have kept open options in case we come up with a new technology for this. This would be followed by a few flags. The first one would be the urgent flag. So I hope you guys understand what urgent is. Now, in case this communication or this packet is really important, that needs to be processed first. So the urgent flag. That would be followed by my acknowledgement flag that this communication channel has been created. So this acknowledgement flag would be made to 1. That would be followed by my push and reset flag. The reset flag. Now, in case I somehow need to reset the count to 0, this reset flag would be used. This would be followed by my synchronization bit. Now, for this each synchronization bit, I will be getting an acknowledgement flag. And now this would be followed by a FIN flag. So, now this FIN flag, what it does is it will indicate that this communication has completed and the transmission is like the data has been transmitted and this communication is done. You can close it. The synchronization flag, this is what we have been talking again. This syn flag or the synchronization flag will mark the beginning of our communication. Now this send flag, in case it is up or it is 1, it means that this communication is done. Now in case it is reset to 0, it means that I have to start a new communication. And now once the communication is done, you would be getting an acknowledgement. And this acknowledgement flag, it what it does is it makes your communication channel to 1. So 0 makes every communication channel to start an acknowledgement, or 1 will make this fin flag, sorry, will make finish flag, fin for finish flag. This will make mark it to 1, making it open so that any 0 can start the communication. So these are the different flags we normally have on our uh, like on our packets, on our TCP packets. This would be followed by another options or offset flags. That would be followed by my checksum. Now we have talked about this checksum, like we know what I am going to receive as my checksum. Now since I know what I suppose, I know that I am going to receive 111. Since each communication, I know what I am going to receive as my checksum, because we have certain flags. Yep, someone is trying to say anything. Let me take it. Thank you, Anaga. Nasiha is absent. So, okay, fine. So checksum, I know I am going to receive 111 because I have those functions. Now, suppose I get something like 110. This will mean that I have got a corruption in this data packet, and I will leave this, I will discard this packet, and this discarding will make this reset flag on, that will make the communication channel to send this packet once again. So then we have a pointer, and that will be followed by certain offset, optional offsets, which we are not supposed to, like, even we don't know, uh, we do not have that much of liberty to discuss, and that is not important to understand. The most important to understand is my destination and the source, the sequence number, this synchronizing flag, this finish flag, and this acknowledgement flag, and a little of checksum, and then the data or the payloads. So this is how my data packet looks on a TCP model, on a TCP protocol. Now, this TCP protocol normally works in my network layer, and it offers me end-to-end packet delivery. So that is number one we need to understand. What it does is it does works in the transport layer in making sure end-to-end packet delivery. Now, guys, anyone having any question, just let me know. It offers you full duplex, and it offers you full duplex and bidirectional transmission. Anyone having any question, just let me know. Because of this checksum, we make sure, or we can have is error-free transmission. Now, anyone having any question, just let me know. Or in that case, we might move to our next protocol, that is my IP protocol. Yep, guys, anyone having any question, just let me know.
No, sir.
Okay, fine. So let us move to my internet protocol. So in case we talk about the packets of my internet protocol, so that was the first diagram that we ever made on the protocol packets. So that is how it would look. So let me try to make it again. Let's create this. So it is a little different, but most of the things would remain the same. A little difference would be there, but most of it would be there. So again, let me, this is a 32-bit packet. The first in our packet IP would be the version. That would be followed by my header length, H length. That would be followed by the type of service. Then the total length of my packet, total. So that is my 0 to 15 and 15 to 31. The identification bits, that would be followed by a few flags and offsets. Flags and offsets. That would be followed by something called my TTL. This is what we have talked about earlier as well. The TTL, or the time to live. That would be followed by my transport. That would be followed by something called the checksum for the header. Header checksum. Now we would be having the addresses, the source, and the destination. That would be followed by a few options or the offsets options that might have padding as well. In case we are having anything to improve, that would be into padding, and that would be followed by my data or the payload. Fine. So, hmm, I hope there is a lot of new things here. The first is the version. Now, I would like you guys to tell me what do you think this version would be like. So I hope you guys have heard about something called IPv4 or IPv6. So this version would define the kind of IP you would be using, whether you would be using the IPv4 or the IPv6. Then we have the header length. This header length would define the length of the header, the complete header length that would be there. That would be followed by the types of services. So this might contain three flags. The first can be DSCP, the differentiated services code point, that might have congestion notification, explicit congestion notification. Another flag that would be followed by these are the two flags you might have. So this will tell you the kind of network, like what is the, like in case there is any problem with the channel, might be it is congested or it is fine. So zero will define that the congestion is not there, and in case it is flagged to one, it will mean that you are having a congested network, and this congested network might mean data corruption. It might mean the packets being sent one after another, might be delay. So it might define that, and when we would be discussing this TTL, this ECN will come into handy. So that would be the type of service, and that would be followed by my total length. Total length of the packet. Uh, so this total length would be like how big is my payload and how big is my complete header. So total length, this total length would be header length plus payload length. That would be followed by my identification flag. Uh, Now, here we discuss about something called the acknowledgement number. Similarly, now what happens is if 10 packets are coming for the same communication. Now, suppose I am sending Mukesh one complete message, and that message has been sent in 10 100 different packets. So the identification number for each of these packets would remain the same. Are you getting me? Identification number will remain same for all the packets that are being sent for one particular communication. Fine, I hope that was understandable for most of you. Then we would be having a few flags. Flags might contain different flags like MSB, and the particular reason for this IP flag would be like whether the packets can be broken down or not. That would be followed by certain offsets. This would tell you the here we had the sequence number. This offset here will be something like the same. Okay, like where is the exact position of this particular uh, packet? Now it is something comparable to my page number. Then we have another important field, that is my TTL or time to live. Now again, let us get back to the same example that we took. Now what happens is I sent a message that was supposed to receive to be received by say Mukesh, but Pavan also gets it, Atul also gets it. Uh, since I am not creating a logical channel between me and Mukesh, so five of you get it. Now you all can find the source and the destination address, and you know that this packet was not meant for me. So what happens to this packet? In case it remains right there, it will congest my network. Now you already have a packet that you cannot process, that you won't be processing. So it will congest the network. And even if it remains on the bus, it will congest the network. So every data packet has something called a time to live. It can remain active for a certain period, say 1 second, and after this 1 second, it will get destroyed. So nothing remains of that data packet. This helps not only in congesting the network, but also it helps in any kind of threat. Now, in case a packet goes to someone who is not the destination, and he is some kind of a threat. Now, in case the packet remains with him for a long time, then he might try to get into my network. Now, in case I have a time to live and he receives that packet, but that packet automatically gets destroyed. So he will not be able to trace me. So that is my time to live. Then we have a few protocols. These protocols would be So it will help you to understand which protocol family it belongs to. Whether you are using ICMP, you are using UDP, or whatever kind of protocol services you might be using. Then it would be followed by my header checksum. This is again doing the same thing. You have the function with you, and that function generates the header checksum at the receiver end. In case the header checksum at the receiver end received created due to that particular function matches with the packet header with this packet header checksum, then fine, the packet has been received as it is at is was supposed to be received. But in case there is any difference in the header checksum and the created checksum, the problem is the message or the packet is not error free. That is followed by again the same thing, the source and the destination address that helps you to make sure where it originated and where it was supposed to be sent to. Then that would be followed by my some options that might help you with the, you might implement security here, you might implement the routes here, the physical route or the logical route that has been that has to be taken, the time stamp at which it was created and at which like it was received. So these are my options. So this is my internet protocol. Now in case anyone has any question, just let me know. Now in case no one has any question, the biggest benefit for my IP protocol is the best effort delivery. The best effort delivery is the biggest benefit of my IP protocols that make sure that all the packets are received at the destination. But it is best effort, not a guarantee. Fine. So it is often said to be unreliable. And it does not create any logical communication channel. Right. So it does not create any logical connection. So it is connection less. Fine. Now, some of you might be thinking like, why are we using this UDP protocol or the TCP protocol or the ICMP protocol to remove this problem of unreliability? We are implementing TCP with this IP or the UDP with IP or any other protocol that will make sure that this connectionless implementation gets reliable. I hope that makes sense. Now, in case anyone has any question, just let me know. Now, in case no one has any question, so let us get back to my UDP protocol, user datagram protocol. Now we learned about TCP. I hope this acknowledgement. Uh, let me see. Okay. Yes. We had the TCP and the UDP protocols. In the UDP protocol, sorry, this was not it. This is what I believe I drew for my TCP, and this is what we drew. Or this was drawn previously as well. So not this one. Yes, I did. We did this. Yes. Yeah. This is for my TCP and this is for my UDP. For a TCP protocol, what happens is the sender sends a request. Yeah, the receiver sends a request and it is met with an acknowledgement. And that acknowledgement means that let us get back to it again. Now, suppose in case we are talking about a UDP. Let us first get back to TCP. A synchronization bit is sent, which means that I am trying to send something, and that needs to create a logical channel between me and you, so that the data that is being sent on this logical channel does not get to anywhere else. So I send you a synchronization channel, yes, synchronization signal that would be met by an acknowledgement. This would be my synchronization acknowledgement. Fine. Now, once this synchronization is acknowledged, our communication channel opens. And now once this channel opens, the data is sent over this logical channel. This logical channel is on my physical channel. This is my receiver and this is my sender. Now here, let me create one more, that is my request. This request comes from the receiver to the, this is my request signal. So once the receiver sends a request to the sender is the one who has the data. The request is made. Now the sender sends a synchronization bit or a synchronization request. Now synchronization request, what it does, it will create a logical channel on the physical channel. Now I am sure you guys understand this. This is what we have talked about. Now suppose this is the sender. A few receivers are connected, means many devices are connected over this channel, R1, R2, R3, R4, and more. This is my physical channel. All these are connected via certain cables, right? I hope everyone understands this. Now this receiver R3 sends a request to this sender. Now what happens is this sender, once it gets the request, it will send a synchronization channel bit. Now this receiver, once it has received this synchronization, okay, no, this is the logical channel that has to be created. This will acknowledge that yes, I have received and I have created this communication channel for you. Now this is the communication channel and all the data that has to be sent from this sender to this receiver would be sent on this channel only. This will not be routed to this like obviously this is using the same cable, but this will be a virtual channel that would be created, and on this virtual channel only this communication would be done, so that this data does not receives does not gets to receiver 1 or 2 or 4, thus creating a congestion in the network. So that is my, what protocol is this? The TCP protocol, transmission control, or a controlled transmission. As against this, the IP channel, the IP protocol that we talked about, that also does not create any channel, any logical channel. So the data can be received by any of these devices. That is why we are having this time to live field, so that in case it is received by except for this 4 R3, it is received by R1 also, R2 also, R4 also, and it is traveling on this channel, this physical channel. So after a few minutes or seconds or whatever the timings might be, it gets yeah, like it gets destroyed, and the channel is not very what do you call yes, the channel does not get congested. So this is the reason why IP protocol has a time to live field and the TCP protocol does not have. So I hope that was clear for most of you, but in case anyone has any question, just let me know. Anyone having any question, just let me know, guys.
Not out there.
Fine, great. So let us move ahead and let us talk about my UDP protocol. Now UDP stands for User Datagram Protocol. Now we have talked about it previously as well, so let us talk about it again. Now this might be my sender, this is my receiver. Now what happens here is the sender, sorry, the receiver sends a request. Now this sender, what it will do is it will start sending over the complete network. So what it does is, since A channel is not created, it sends multiple files, multiple packets. It can be said something like a broadcast. Uh, broadcast like again, I am sending it to multiple users. Now, one request has been created on me. I am sending it to all of the people. Now, anyone who is there on the channel might receive it. So that is my UDP. Uh, Again, suppose let me take now this is my sender and I have a multiple receivers. One, two, three, four, five. I have a lot of them, right? Now what happens is in case of a TCP protocol, I create a logical channel to this. But in case of a UDP, I do not create a channel and I broadcast this data. This data can be received by anyone on the channel. I hope that makes up sense for most of you and you guys were able to understand this. Someone has said anything? Yeah. Okay, fine. So in case I talk about the packets of the UDP, so the first one would be my version, my version first. That would be the first 4 bits. That would be followed by another 4 bits of header length. Let me write it as HL. That would be followed by my same protocol, yeah, like the same fields that we used here. Right. Hmm, a few flags. That might be ECM flag, my DSCP flag. So those flags might be used. That would be followed by my total length. Total length. This would be followed by my identification, followed by a few flags and an offset. That also would be having a time to live. That is also very important for this time to live. Then the different protocols that we might need. That would be followed by the same things as we used previously. That would be the header checksum and the source address and the destination address, and followed by might data. Yep, the difference you might find here, the payload. Yep, the payload. Same thing here also. I don't think there would be any difference, but in several packets in the payload, you might find the source port and the source port and the destination port also. So that might be in most of the packets you might find like that. You are having the source address and the destination address, and here you have the source port and the destination port. Now source address would be the IP, destination address would be the IP, and the source port might be port 81 that you might be using, port 226 you might be using, whatever ports you are using, followed by my payload. uh, Again, it works in the same manner as my IP protocol. Hence, most of the fields are same and most of the fields work in the same manner. And as we talked, it is again similar to my IP protocol. It is certainly connectionless and unreliable. And so that is what we have for UDP. Now coming back to its usage, uh, it might be used for broadcast. Any kind of broadcasting would be supported here. Uh, it can also be used for any kind of multicasting, since again it is sending data to multiple users, so it can be used for multicasting and broadcasting. So that is what we have for UDP. So you guys have been talking a very little today. So any questions, please let me know. Now this brings us to our POP protocol. I hope you guys know that this POP stands for Post Office Protocol. So now how it behaves. Uh, Suppose I have a sender here and I have a receiver and I have a receiver here. Now between this sender and receiver, we have a communication network, and it might be a local network in case we might be using SMTP server. So the type of protocol this POP would be using. might be POP3, might be SMTP or whatever. It is using a communication media or communication network. Now you are having a mail servers. You are implementing mail servers. You are implementing a mail server here as well. This is the sender's mail server and this is the receiver's mail server. This might help you in cross-platform transmission as well. Now, your communication goes to the server and it in turn is being transmitted over the channel. Now, this channel is nothing but it is transmitting it to the next server, that is the receiver server. Now, this will calculate where to send this. The address of the server would be defined and it would be identified. And once it is identified, it will be sent to the receiver. Now, this is my POP protocol. It might implement SMTP servers, more protocols. It might have POP3 or ICMP, IMAP. So we have different POP protocols which might be implemented. Now, I'm not sure how much did you understand. Guys, in case you do not come up with questions, I might not be able to understand. Now, we have a protocol called the SMTP. That stands for Simple Mail Transfer Protocol. Right, Simple Mail Transfer Protocol. Now, whenever you are sending a mail via a server, the first path is from you to your server. This will use SMTP server. Now, from your server to the through the network to the receiver server. This will also implement SMTP server. Yes, protocols, transfer protocols. Now, to receive this mail, you need either POP3, SMTP server might not work here. So you use POP3 or IMAP. These are the most popular protocols that are being used. Yep. I'm not very sure how many of you have used the Outlook application. Hmm, and like every mail is using the same methodology. It might use IMAP or POP3. That is not our concern. Our concern is to understand how it exactly works. So, those who have seen the Outlook Express working must have seen that every time you connect to the internet, you did a download messages option. Now, let me show you. Outlook images. This is how it looked like. And had those and you had this send and receive. So whenever you connected to the network, you had to do a send or receive. And now this took a lot of time. Now even you have 5 mails, it would take, depending upon the connectivity you had, depending upon the bandwidth you were using, it would take some time to download all the mails. And now this download was done through either POP3 or IMAP. Now you are sending a mail, that is fine, that is using SMTP. But receiving and downloading those mails required another protocol, that was my POP3 or IMAP. Now, in case I talk about this POP3 or the IMAP, how it worked or what was the exact procedure, let me tell you. The first thing that we did was the server and the client connected. Client server connection was made. That was the first step. And the client and the connection was this end, right? This end, the receiver and the server used to connect. Now, this would in turn, once this connection has been set up, all the mails and the attachments would download the mails and the an attachment from where, my server. Now once it has been downloaded, it would be saved on my device, right? And once it has been saved, the server would in turn delete everything that is there on the server. Since it is already saved on your device, This deleting will not affect your copy. So this is how this worked. And now once this saving and this downloading is done, it would end the transmission. So this is how this POP3 or IMAP used to work. Normally, this is how we configure this mail process. Now we are talking about a time where those servers were not that strong. So normally we had to delete. Now in case I am configuring an IMAP server, now what happens is the process remains almost the same. Now instead of this saving and the deletion on its own, it was who you used to delete the attachments and the mails from the server. So this request was initiated by the user, and in case of POP3, it was initiated by the server itself. So this was the difference between my POP3 and my IMAP. Still today, we are using this IMAP. Now, suppose I am establishing a connection with my, suppose I am using a mail. I'm really fed up of this. So I get a lot of messages here, a lot of mails are here, right? So what I do is I am deleting the copy from the server and I am not having anything on my device. So this can be compared to the IMAP process, that everything is there on the server and I am deleting it. This is not an server initiated request. This is the user initiated request. I am deleting it. Whatever it is, I am deleting. So this deletion is done by the user. So this is what we have for POP3. Now, anyone having any question, just let me know. Now, in case we are talking about this POP3, since all the messages are being downloaded on my local device, the attachments inclusive, you can, even if you're offline, you could have used this application or you could read all the mails even if you are offline. So that was the biggest advantage. Now this again needs to be worked on. Suppose we talked about this receiver. Since this is the place where we are using either POP3 or IMAP. So this is my server and this is my client, right? And we are using the POP3 protocol. Now what happens is whenever you log in, this is normally what we do. We are providing it with a username. This username might be my email ID. This is met with an acknowledgement. That is an acknowledgement. Now, this sender will send something called a password. That would also be met with an acknowledgement. This will be met with an acknowledgement. This is my acknowledgement. Now, once this acknowledgement is done, what you do is you refresh your mailbox. Refreshing your mailbox means that you want all the mails that you have received. Right. So you do a request. Now, once this request is received, it will list all the mails that have been received by you or that was sent to you. Fine. So it will send you a list. Now, once you have the list of everything that was received to you, what you do is you will ask to download. Now, once you request a download, it will give you or download every mail one by one from the server to the client, and whatever it is sending, it will delete it from here. So that is how it normally works. Uh, the best thing about it was on a physical device. It was downloaded on the physical device, so you could access this without any connectivity. Even if you're offline, you could use this. So that was the biggest advantage. Now I hope that was clear to most of you. Fine, this brings us to another protocol, that is the HTTP protocol. Now, in case we talk about the HTTP protocol, I believe you guys are aware that this HTTP uh, stands for Hypertext Transfer Protocol. We make it a little bigger. Hypertext Transfer Protocol. Now, guys, I believe this was something quite uh, boring kind of thing, but still, we need to learn all these things. So, might be I understand. Still, you guys need to keep up with me, and whatever questions there might arise, just let me know. We need to, we in case needed, we might discuss things again. Or let us, before moving on to HTTP, let us discuss the SMTP, since we started